A lot of the missions so far have been demonstrations, but the biggest thing right now is we need to transition to operational.
Hello, everyone. Welcome to the Space Policy Show. I'm Colleen Stover with the Aerospace Corporation. Today, we've got on two experts from Aerospace, and they're going to be talking about how stuff works in the world of ISAM. Now, if you don't know what that is, that's in-space servicing, assembly, and manufacturing. There are other acronyms that are used: OSAM, on-space servicing, assembly, and manufacturing. There's RPO, rendezvous and proximity operations, or even RPOD, which is with docking included. But before we start, I want to make sure that our guests have a chance to introduce themselves. So Shannon, can we start with you?
Sure. My name is Shannon Zirbel. I've been at Aerospace about 9 years. Currently, I am a section manager in the vehicle engineering department, but my role related to ISAM is as a focus area lead for the Cosmic Consortium for Space Mobility and ISAM capabilities, which Aerospace is the lead for and will be kicking off very soon.
Right, that's the NASA effort, right?
That's correct.
Brianna?
Yeah, my name is Brianna Andrus. I have been with Aerospace for 5 years. I currently serve as a Level 2 portfolio analyst for a NASA customer in STMD under the technology demonstration missions. And my position related to ISAM is I am the logistics lead for Cosmic, as well, working with Shannon.
Excellent. Well, thank you guys very much for being here today. I'm excited to see what kind of information you can share with our audience. Some of them might be very fresh to the world of ISAM, and some of them might actually learn some things they didn't know. So, Brianna, I'm going to start with you. What is ISAM and where is it?
Yeah, so ISAM is in-space servicing and assembly and manufacturing. The term became a hot topic whenever the Office of Science, Technology, and Policy, otherwise known as OSTP, put out an implementation strategy in 2022. So basically, ISAM is an emerging set of capabilities that enables inspection, repair, upgrades, modular assembly, and construction of space assets.
Okay. And it's specifically in space as opposed to on orbit, right?
Yes, ma'am.
Shannon, do you want to add anything?
Sure. Yeah, the previous acronym was OSAM, as you mentioned, on orbit. And the distinction with this new report that came out from NASA, from that office, is to increase the scope, right? To include in space things that are, planetary missions, lunar surface. So it's just a bit larger scope. And you mentioned a bunch of the other acronyms as well that are related. Another one is the DoD uses space mobility and also space access, mobility, and logistics. There's a lot of overlap in those. One of the things with space access, that also includes launch, which ISAM generally is just focused on the in-space piece. But, the overlap there, anything that's happening in space, we'll see a lot of that. And we'll talk about that today as well. And you mentioned RPO, docking and capture. So those rendezvous proximity operations, those all become very important for the servicing piece of ISAM.
Right. So the servicing, it sounds like that's one of the goals of ISAM, right? But what other goals are there, Brianna, in terms of, what are we trying to do up there?
Yeah, so for on-orbit servicing, it really focuses on satellites that are on orbit, in-space
around the Earth, right?
Yes. And so in space servicing, assembly, and manufacturing, the primary goal is to construct, maintain, and repair structures and vehicles and habitats that are including on orbit, but also other planetary surfaces or elsewhere, which is why it's so crucial for the advancement of space exploration, satellite operations, and even future human space missions.
And so what is the difference between, having something on orbit around Earth, on orbit around the moon, maybe on orbit around Mars eventually, versus being on the surface?
So there are a lot of logistical differences when something's orbiting versus being on a surface. There are other opportunities that come with surface exploration as well. So we'll talk about in situ resource utilization when we're talking about ISAM, particularly with the manufacturing piece. If we can use local resources, either from an asteroid or another planet or moon, then that increases our capabilities.
Right. So on the moon, what are they talking about being able to use in terms of the in situ resources? It's
Yeah, there's a whole consortium called LSIC that also, there's a lot of partnership between what they do and what we're looking at for ISAM within Cosmic as well. But the lunar surface is a big piece of what they're exploring. And so there it's called regolith when it's lunar surface material. But being able to create roads or buildings from this regolith is a big area of exploration right now. And certainly there are more areas of research that I'm not as deeply involved with, but definitely a lot of creativity to come from that.
Yes. Yeah. And of course, that's, it's much easier than to use what you have on the surface than it is to try to bring it up from Earth. Right.
Absolutely.
Brianna, did you want to mention anything else?
No, I think Shannon covered it perfectly.
So who are the players here? I mean, you've talked about assembling and manufacturing. You've talked about servicing, refueling, inspection. Shannon, who are the players we're talking about that are involved in all this?
Yeah, in short, everybody. We have national players, international players, a lot of companies. Japan has been involved in things. We work with Canada. Canadarm is one of the robotic arms that's used on the International Space Station, and that certainly adds a lot of capability. That's within the ISAM realm of space exploration. There are civil companies, that would be NASA, defense side of government, DoD, and then a lot of commercial companies. There's a lot of new startups also, include not just the existing powerhouses in space exploration, but new startups looking at ways to do different pieces of the ISAM puzzle.
Yeah, you mentioned Canadarm. That is a Canadian company, and we actually, our last episode had a guest give us a rundown of some of the robotics that they've been doing, and they've had on the space station and what they're going to have on the Gateway. So,
yes, very cool stuff.
Brianna, do you have anything to add? What other players are we talking about?
Yeah, so we have players now versus players of the future. So I know NASA and DoD are investing through OSAM-1. There's also DARPA's Robotic Servicing and Geosynchronous Satellites, otherwise known as RSGS. Commercials really starting to invest. They're looking for viable business cases. A lot of the missions so far have been demonstrations, but the biggest thing right now is we need to transition to operational, and that's what we're working on currently.
Yeah, I've heard a couple of commercial players talk about we're in the endless cycle of demos. We need to get on. We need to get actually, yeah. So what kinds of, beyond you talked about demos, you talked about getting things actually operational. What are you excited about? The cool stuff that might be next to be, well, we can talk about what's on, but also what do we have coming up shortly that you are excited about?
Yeah. So we have some mission extension vehicles, otherwise known as MEVs. They're essentially like life extension backpacks. These are great for if a client has satellites that weren't designed for servicing. It's also used as a capability enhancement. We're also doing some on-orbit refueling. So companies creating tags and critical markers for servicing, refueling craft to attach to their different satellites, and then also active debris removal. That's a big one as well.
And so life extension, what's the end game there?
I would say the big end game is to create a more sustainable space environment. So instead of your satellite having to be at its end of its life cycle, those mission extension vehicles will add about 5 years to your satellite, which is good as cost effectiveness, affordability, and sustainability in space.
Right. Because then they don't become inactive debris as quickly. We don't have to launch up as much, perhaps, and use all those resources too. Shannon,
Yep.
what are you excited about, Shannon?
Oh, I just want to tag on to the mission extension for a minute. These are great capability enhancers, especially, for things that have been built already that weren't designed with refueling ports or, other capability for attaching with robotic enhancements. These little mission extension backpacks, like these can just connect to any vehicle, and already there are some examples that I think we're going to share in a minute about what those are. But it's a very exciting area because it enables capability right now, not just things that have to be considered in the design phase for the future. There's also some other things, we can recycle materials from retired satellites, ones that are past their life, already deorbited. Maybe we can go out and get some materials, as we were talking about for that manufacturing piece, or, remove a robotic arm that still works and attach it to another satellite. There's also inspection and monitoring. So if you have a satellite that isn't responding the way that you think it should, maybe a little inspection robot can check it out and give you some feedback. And then, repair, maintenance, and surface construction, like we talked about earlier, with on surface building things, either out of regolith on the lunar surface or in the future on Mars, creating habitats or other constructed materials there.
So you talked about a lot of stuff right there. I have lots of questions. Going back to the backpack, I love this idea. I'm thinking Dora the Explorer with the backpack on. She's got everything she needs in her backpack. How do these things connect? I mean, can you tell us just kind of rough idea of how these things connect to something that's not prepared for connection and service like that?
Yeah, I mean, they have to identify some kind of connection point. So for the ones that exist, the company that's building these, Northrop Grumman Space Logistics is the name of the branch of Northrop Grumman.
That's right.
They identify places on the client satellite where they can connect. Here's something, it wasn't designed specifically for this purpose, but we can connect here and create this point. And then, they can carry some additional fuel. There could potentially be in the future, an additional capability like a robotic arm, another camera, some other sensor as well. But right now we're talking mostly about just, fuel, maybe some control ability as well that would be added with that extension vehicle.
Nice. And so you also talked about recycling, and this is definitely a benefit, right? What kinds of, either one of you, if you wanted to talk more about the recycling, I'm fascinated by that recycling. We could have, junkyards in space where they're in a kind of graveyard orbit, go up, collect things, bring them back down to use elsewhere.
Yeah, I'll start for a minute, and then Brianna's really interested in sustainability as well. So I know she's going to want to say some things there. One of the challenges with recycling is you have to have permission from, even though it's retired, it's abandoned, you still have to have permission from the owner of that satellite. So, there's some policy challenges that might come with that. But once we can clear some of those hurdles, then there's a huge amount of wealth of resources that are already in space that can't function anymore. And rather than having to launch more things up as we are able to use that, then that creates a source of material for us for the future.
Definitely. And then, of course, you've mentioned the policy challenge, and this is the Space Policy Show. So, Brianna, what do you want to add?
Yeah, I was going to say, so it really does create sustainable space operation. It reduces the reliance on Earth-based resources, which is really important. That includes like extracting and utilizing resources from different bodies, such as the moon or asteroids or fuel or construction materials. So that's a really big portion about, creating a sustainable space operation. And then also too, adaptability and flexibility. It enables the modification or reconfiguration of spacecrafts or satellites to reconfigure to changing mission requirements that are changing all the time. So this flexibility allows for the deployment of multi-purpose platforms in addition to new instruments or payloads being implemented. So there's so many different factors that are really beneficial.
No, I think that, and of course that sustainability, that sustainable space environment, not having a bunch of inactive debris or being able to clean up debris that's already floating up there or reuse it somehow is going to benefit sustainability on Earth, on the ground as well, right? Like you said, not using as many of our finite resources in order to develop, build, launch. Yeah.
So, absolutely.
What other things then? So the ISAM is the in-space servicing. We've been talking about the servicing. What about the assembly and the manufacture? I'll start with you, Brianna. Why do we want to do that in space? And what actually, let's just talk about assembly of reassembling. You've kind of mentioned that. What about manufacturing? Can you just introduce our audience to manufacturing in space? Like, what are they making up there they can't make down here?
So it gives a big enhanced capability for construction of larger structures. So such as space stations or habitats. Everybody's familiar with, the International Space Station, the ISS. These are things that had to be built over time that are not literally feasible to launch fully from Earth. So it enables the creation of more compatible and capable versatile space infrastructures as one. And then the space infrastructure development. You can facilitate the construction of large-scale space infrastructures, such as also like space-based telescopes, solar power stations, research facilities. These are all different things that can be built in space that we can't launch from Earth.
Right. And the reason that we want to have in-space telescopes is because we can then see further, right?
Yes. And that goes into just like building, like, essentially the next generation of the JWST, for example. So
yeah. Shannon?
Sure. Yeah. Just maybe adding on to that a little bit. Another piece is launch, right? Launch is a huge factor in how things are designed right now because they have to survive that very volatile environment, especially vibration loads that come from the launch. If you can assemble in space, if you can use materials that are already in space, so you're manufacturing in space, then you can design things that don't have to survive vibration loads of launch. It also brings in this new piece. We have to figure out how to test things in space. But right now, when we're testing in a 1G environment on Earth, we're already having to do a lot of concessions about how we test things. So it does introduce new challenges, but also huge opportunities for manufacturing in space and what we can do when we eliminate that need for surviving launch.
Right. So you talked about some of the, you talked about one challenge, right? Surviving launch with the, all the jiggling. What other technological challenges besides, figuring out how to test in space? What other technological challenges are there?
Yeah. One of the big ones comes back to the servicing piece, right? So the safety of and reliability of connecting with a client spacecraft. When we talk about the rendezvous and proximity operations being a big piece of servicing, that's it right there. You're going to be interacting with another satellite and they don't want you to blow them up or, if you connect carefully, but then you can't release afterwards, that also becomes a big piece. So not just the docking and then performing whatever your service operation is, but also being able to release at the end of that. I guess another piece we sort of did talk about, but the testing is just a huge concern. How do we do that? How do we figure out what the inertias are in space? How do we determine how it's going to perform its functions that we normally do in a nice big laboratory on Earth? So just, I guess, a little bit extra emphasis on the testing.
Yeah. And that you think that will rely heavily on robotics?
I think that's going to be a big part of the solution, certainly.
So, Brianna, do you have anything to add to that?
Yeah, I would say I have 3 items that I really think are important. The first is microgravity environment. Yeah. Working in a microgravity environment has a lot of challenges handling different tools and techniques that are designed for Earth's gravity system. So those might not work as effectively. So we need to develop these specialized tools and robotic systems that can work in microgravity environments. I would say the next is precision and alignment. Achieving a precise alignment and positioning of components or different structures in space is challenging due to the absence of gravity. So the need for extreme accuracy is really important to ensure those proper alignments during assembly or manufacturing processes, to make sure it requires like advanced sensing, control, different robotic systems. And then I would say my last is power and energy. ISAM activities require reliable and sustainable power sources. So developing these efficient power systems such as advanced solar panels or compact nuclear reactors, these are essential to make sure all these activities can be completed.
Yeah, certainly. I've heard a lot of people talking about the power. So going back to the precision thing, though, I'm curious, what kinds of are there developments for completely robotic kind of precision alignment type things with all the sensors and using AI, or are we talking about things that are being kind of directed from Earth?
Yeah, one of the big ways for aligning things is using, they're called fiducial markers. They're those funky little things, kind of look like a QR code. There's like little black squares and white squares randomly. Fiducial markers are just a great way because most satellites have cameras. You can use those to line yourself up. If you already have those on a client spacecraft, then the service craft can use those to help have a precise alignment. So that's one of the ways that we can address precision.
Interesting. Well, interesting. So before we go to the next question, I just want to go back to something that Brianna had talked about, that microgravity or environment and manufacturing. So we haven't really touched heavy on the M of ISAM. So can we kind of give our audience an idea of what kind of manufacturing, besides assembly of large platforms and space stations, what about the piece? What does that look like?
Yeah, I think there's actually an interesting order to the SAM of ISAM. Like S is what's happening right now and will continue happening in the future. Assembly is probably next, and manufacturing is probably the furthest out. So we haven't seen quite as much of that yet. But in a previous conversation, you mentioned some of the interesting, research that's going on the space station. You talked about like making cosmetics in space, which I got to tell you is new information to me. But I love that creativity. Like, how can we use an anti-gravity, but an in-space environment? Maybe it's the vacuum that becomes really important for that manufacturing piece about something that you wouldn't normally associate with space, like cosmetics. I think just the possibilities are endless, and creativity is going to allow us to really just delve into areas we hadn't ever considered. So yeah, there's a lot of new manufacturing that could happen, things that could be enabled that we haven't even considered yet. And whether that's cosmetics or pharmaceuticals, and some of that pharmaceutical research is important because we're sending people into space, but we may find things there, or there's cultures we can grow in space that we can't grow on Earth that can help our life on Earth as well. And NASA has just decades of history of how things that were created for the space environment benefit our life on Earth. And I think that's really important for a lot of people to hear, that we're talking about in-space manufacturing, but that work that's done in space may really, provide answers to the climate crisis, or the just really improving the future of life on Earth.
Yeah, I know I've read a lot about the protein crystals that can be grown in space and how they're just so perfect because they don't have that pressure from gravity.
Yeah.
Do you want to mention anything else?
Yeah, no, I think Shannon hit on it perfectly.
All right. So then we only have a couple minutes left. So what kinds of technologies have already been demonstrated, and how has ISAM been involved in that? Can I start with you, Brianna?
Yeah, of course. I know JAXA, the Japan Aerospace Exploration Agency, they had an ETS mission in 1998 that demonstrated rendezvous and docking for 2 spacecraft. In 2007, Orbital Express also demonstrated autonomized rendezvous and capture, transfer of propellant, and transfer of a spacecraft component. And it's evolved a ton, like how Shannon talked about earlier about Northrop Grumman Space Logistics. They have 2 active MEV missions right now. that are a great alternative for spacecraft that don't have, refueling ports. Also, just like Shannon said as well, NASA's doing a lot of ISAM activities as far as, the ISS is built to what it is today from in space, assembly and manufacturing. And NASA's also had 3 different robotic refueling missions. So these are things that are in the works, and we're just trying to keep taking these lessons learned that we have from things that we're building now, and then making these demos that are going to help make our missions operational in the future.
That's right. Demos. Got to have a demo before you actually are able to get a contract. Right? So you kind of hit on, these things that have flown and proven themselves in this kind of test ground. And of course, creating a business case for the future space economy or ecosystem. It's that business case. So we do have some more things to do. So Shannon, did you want to add anything to that?
Yeah, absolutely. We talked about things that have happened. Mostly they've been demonstration. And we said earlier, we've got to transition into operational. That's a huge part. But those mission extension vehicles that Brianna mentioned from Northrop Grumman and that we've talked about already, those are huge. Those are operational. They are performing ISAM right now. They are performing, they're providing that service to the client spacecraft that they are connected up with. And that's just huge. Like ISAM is happening right now. It's not just demonstration missions. We do have some examples of real operational missions.
That's a good point.
A lot coming. Yeah.
Yes. Well, so what's coming? What's something that you can share with us?
Oh, absolutely. We mentioned earlier OSAM-1. So that's NASA's mission that they should be launching maybe next year, perhaps, if all goes well. And then Brianna also mentioned DARPA's robotic servicing mission that's coming up. So those two are in the very near time frame. Again, demos, we're going to see that, but there's a lot of commercial missions that are planned for the near future and going forward. And there's a difference between orbits as well. So things that are launching to LEO are a little bit more accessible. However, spacecraft that are in GEO tends to be, our hundreds of millions of dollars of, satellites, where those clients are going to want to service if they can do that for maybe $10 million instead. So we'll see some things going to GEO before they actually hit LEO. And some of those examples, on-orbit refueling, that's probably the lowest hanging fruit, right? Like if we can come up and have a port already designed, then we can transfer fuel, or, that requires some previous design on the client's part. But doing those fiducial markers is another easy access. Put this on your spacecraft. It's going to help us in the future. It's not going to cost you much. So that's another one that's pretty soon in the future will be happening. And then another one that's interesting, and it brings up this policy piece again, is the active debris removal. There's so much need for that. We hear a lot about it, LEO, we're putting up thousands of satellites just for, specific constellations. And those are going to be deorbited eventually. And so there's just a lot of junk that's accumulating in and around LEO. Debris removal needs to happen. We know it needs to happen. How is it going to happen? So it opens up those policy questions that have been discussed on the Space Policy Show in the past, I'm sure. Figuring out those policy pieces so that can happen is a huge part for the future. That's going to really be important.
Right. And of course, the rendezvous proximity operations, that's kind of the backbone of the refueling that you talked about, is the lowest hanging fruit. It's the backbone of debris removal, inactive debris removal, being able to capture it somehow, right? Maybe not with as much precision. But yeah, there's all kinds of things out there. We're nearing the end of our time together. I hope that our audience got some more information about just kind of the parameters of what ISAM looks like and what it could look like even. I wanted to ask you guys any last comments. So Brianna, is there anything that you want the audience to take home with them?
Yeah. For me, I would say ISAM is the future, and addressing these technological challenges requires collaborations between space agencies, private companies, research institutions to make sure we're creating and developing innovative solutions and pushing the boundaries of the ISAM capabilities.
Absolutely. Shannon?
ISAM needs everybody to work together to make it happen. We've talked a little bit about those pieces. The client and the servicer have to have, some collaboration there. I'm just creating an environment where we can work together and advance our capability as a nation is going to really help us advance into the future and take advantage of all of those opportunities that ISAM offers.
Yeah, certainly. And it's not just the US, right? So space is an international collaboration point. And so we have talked about the idea of setting standards at the international level for customers to work together. And, whether it's a rendezvous and proximity or other things, sending up, creating an acquisition model where you're sending up new things that have serviceability options built into them, right? Like, how does that work? So, well, thank you guys very much for being here. So if anyone would like to learn more about ISAM, you can certainly go to our show, episode 126. That's right. We're on 126. And we went to the International Confor's annual conference, and we talked to some leading experts there that are actually in the business, and even have some tech talks from people talking about their cutting edge technology that is both being demonstrated now or has been demonstrated, as well as things that are way off into the future, like floating platforms around Mars and stuff. So csps.aerospace.org is where you can find all of our research papers. And of course, you can browse all of the space policy shows that we've had. We're also, all the shows are on YouTube, as well as your favorite podcast platform. Thank you to James Liggins, our technical director, as always. And thank you, everyone, for joining us. Until next time.